All right, just doing some desaturation tests here, basically simulating a dead short. I moved my wire coming from my big leaf cap. What I've done is I've jumped two sections of the cap in parallel to make sure there's enough amperage. It didn't actually seem to change this, but I have moved this wire to come in here. So it actually reads the current flowing through that wire and then through this MOS IGBT to dead short. It's actually basically pulsing these. When this turns on, it actually shorts these out. And so this here reads the cap voltage. That there is actually measuring current from my brain board, and it's 1.4 something. I have it written down over there, 1.4 something millivolts per amp. So as you see there, I had 900 amps. That was at 200 volts. So now I'm going to do another test. And this is how it ramps up. So this little bump at the start here, that'll be the IGBT turning on. This will be the current ramping up. As you can see, it's an accelerated curve. That's because there's very little inductance in these wires. Basically, that will keep going down like this and then probably smooth out once it hit resistance saturation, if there was enough amperage available in the cap. We're just here to measure how many amps are going to flow and where the desaturation detection will turn on, which is about here. That's about where it's turning on and shutting this all down. So let's try again here. I'm going to turn on my high voltage power supply, and we're going to go for all the way up to 300 volts. So I'll make sure everything's on there. And then we'll watch this. You can see the voltage climbing there. It's going to start ticking soon. Should show up. Basically, that's the amperage. You can see a bit of ringing as it shuts off. That's the amperage flowing around. There's going to be 200 volts. This makes my heart go, oh, that's not good. Turn that down because something really funny happened there. Let's go like this. And turn this back up. Just see if anything, see if that comes back and see if I can see it better. I just moved over. So that's fully cranked, 385 volts. And I'm just going to store that. You see it pulsing all the power it can take. I'm going to turn that down because that's really hard on everything. Although this thing is actually made to take it. We'll watch the voltage drop down. So you can see as I turn the voltage up, the desaturation detection actually works faster. It works. It's pretty amazing. I love this stuff. So right there we're hitting. Now there's a good chance we're actually getting to a limit of the current sensor, but according to that, that's 1.3 volts. So 1300 millivolts. Let's go here, use the calculator. And I wrote my number down earlier, so it's 1.42743. So that was 910 amps at 385 volts. That's pretty amazing. So basically, I am at the limit of the current sensor, but that was fully cranked, so I'm going to change out the Zener to the 2.5 and just see if it reads any different. And that should give me my full, 1600-ish amps.